So, what we're going to talk about today a little bit is projectiles. The purpose of this is to kind of just introduce you to some basics of projectiles and just kind of the math behind that as well. As we get started here, wait, what in the world? Mr. Martin's here. I guess we'll let him in. Mr. Martin?
Hey, Mr. Hauser, how you doing?
I'm doing well. How are you?
I'm good. Hey, do you have a minute? I wanted to talk about projectiles.
Projectiles?
Yeah, projectiles.
Oh, you are not going to believe it. It is your lucky day, sir. I was actually just recording a video for class about projectiles. So would you like to just kind of chime in here and help you out a little bit?
Yeah, that'd be great.
Oh, fantastic. What we have going on here, and I just want to show a quick video before we get started. The former Division I college athlete, Mr. Martin, is just shooting a basketball here. We can see it follows just this nice parabolic path. Well, let me just show that one more time. And once again, we're in Logger Pro. Perhaps you've used that before, perhaps not, but it's what professional lumberjacks use to do video analysis. What we're going to actually do here is track the motion frame by frame of this video so we can kind of get a better feel for really what's going on in projectile motion. So a projectile is just anything flying through the air going in two directions. So that means both horizontally and vertically. So what I'm going to do is, and Mr. Martin, is this okay with you? Are you following along with me here?
Yeah, this is great.
Awesome, great. I am going to just click frame by frame so we can kind of see what's happening to the positions of this this basketball over time. So nice shot, by the way. Really, really top notch.
Thanks.
You're welcome. All right, so you can see it's kind of faint, but I do have these little blue dots as I increase frame by frame, and it's really letting us get a nice picture for what that ball is doing as we go frame by frame and move forward here. So the cool thing about Logger Pro is we have this nice parabolic path, but the best thing is, and Mr. Martin, this one's big. You are taking notes, correct?
I am.
All right, fantastic is we get these two graphs. So on these two graphs, and you can see on the vertical axis, it says X and Y, and that represents position. And on the X axis, that represents time. So we have two different sets of data. The red data right here represents what's going on in the X direction, and the blue data represents what's going on in the Y direction. So, Mr. Martin, I know you're here because you want me to drop some knowledge, and we all want to know more about projectiles. Let's be honest. What's going on? We have this line in the red that represents what's going on with this ball in the X direction. So what does that tell you?
Well, I've noticed that if we have X or the X direction on the Y axis and we have time on the X axis, well, that means that's a straight line there. And anytime we have a straight line on a position time graph, that tells us that that's moving at a constant velocity. So it looks like in the video, the basketball is moving at a constant velocity in the X direction. What about the blue dots, Mr. Hauser?
Well, those blue dots, and one thing I wanted to tell you was if you heard some background noise, that was actually someone else calling in wanting to try to find out about projectiles. So this is just you and I right now. So this is a one-on-one sesh here. So Mr. Martin, I think that's great. That's spot on. You're right. That X direction is moving at a constant speed, and the Y, man, we have that nice parabola. And I'm trying to remember way back when we saw things moving in parabolas, and to me that looks like some uniformly accelerated motion. So it's accelerating in the Y direction. Mr. Martin, any idea why would that be accelerating in the Y direction?
Well, something I noticed there, Mr. Hauser, is that if you look at just in the Y direction, up and down, the dots, as they go up, they get closer together.
Yeah.
We learned earlier this year in my class that if those dots are getting closer together, that object's slowing down.
Huh.
And then as the ball continues to fall, those dots are getting farther apart. And as those dots get farther apart, we learn that means it's speeding up. So, like you said, that shows that in the Y direction, that ball is accelerating. And I've got a hunch that it's accelerating because of gravity.
No way. So if it's accelerating due to gravity, that would just mean, like, in the x direction, we're saying it's moving at a constant speed. In the y direction, since it's just accelerating due to gravity, that I guess that would be negative 9.8 meters per second squared, right?
Negative 9.81 meters per second squared.
Oh, beautiful. So I think we could say in the y direction. How's that song go again?
I don't know if I know the one.
Oh, the one about things falling freely.
Oh, you mean free falling?
Oh, there it is, ladies and gentlemen. So that's where it comes down to right there. As an introduction to projectiles, we have motion going on in two directions. They're completely independent of one another. In the x direction, a projectile, something flying through the air, is moving at a constant velocity. And in the y direction, as you see in this nice parabola, it's moving at negative 9.8 meters per second squared. We'll recap that, do some fun math later, but thanks for joining us. Mr. Martin, great to see you as always.
Always a pleasure to talk to you, Mr. Hauser.
Catch you on the flippity flip.